Hello everyone. Hope all of you are safe and happy at home. I wish you all a very happy and safe Rongali Bihu. Since we have lost a lot of instructional days, it's high time for us to think something differently. So let's learn something. Even though these types of learning will not substitute the classroom teaching, we all know that something is better than nothing. I already uploaded a link in the Parents Alarm which will provide you a lot of study materials prescribed by CBSE which will help you to solve the questions which may likely to come in the board examinations. Those study materials include videos, PowerPoint presentations, short answer and long answer type questions, and MCQ questions. If you have any doubt in solving those questions, you please WhatsApp me in the phone number which is provided in the Parents Alarm itself. Now let's start learning the first chapter, that is real numbers, which is actually a chapter which will give you a lot of application based questions, even though the concept has already been learned in the earlier classes. Before starting the chapter, let's just recapitulate whatever the things we have learned in the earlier classes.
To understand what real numbers are, all you need to understand is the number line. Positive numbers to the right of 0 and negative numbers to the left of 0. You will hear various complicated definitions of real numbers, but here's the simplest one. Any number that can be plotted on a number line is called a real number. Let's look at a few examples. Say -2. Yes, it can be plotted on the number line. It's this point. So -2 is a real number. What about 0.5? Even though it's not an integer, it can be plotted on the number line. It will be somewhere here. Now let's look at another number, √2, which is also called as square root of 2. If we calculate the value of √2, we get it as 1.414 approximately. The digits after the decimal point do not end. These kind of numbers are called non-terminating decimal numbers. And yes, these numbers too can be plotted on the number line. Plotting a non-terminating number might sound weird, but yes, it's possible. So √2 is also a real number. And what about the special number pi? It approximately equals 3.14159. Pi is also a non-terminating decimal number. And yes, it can be plotted on the number line, which makes it a real number. So that's our definition. Any number that can be plotted on a number line is called a real number. Now let's talk a bit about the different kinds of numbers we know. The first kind is numbers with terminating decimals. Numbers like 0.375. The number stops at a point and does not go on and on. Then we have non-terminating recurring decimals. Numbers like 0.6666 and so on. The sixes don't end. It's called recurring since the same number reoccurs, and non-terminating since it reoccurs infinitely. And the third type is non-terminating, non-recurring decimals. We just saw an example of this type, √2. It approximately equals 1.4142 and the digits after the decimal do not end. Hence, it's called non-terminating. It's called non-recurring since there is no specific pattern of reoccurrence. Broadly, these are the three types of numbers we see in mathematics: terminating, non-terminating recurring, and non-terminating non-recurring. These two categories together are called rational numbers, and the numbers in this category are called irrational numbers. These two categories together form real numbers. This is the other definition of real numbers. Rational numbers and irrational numbers together form real numbers. In the second part of this video,
So students, now we come to know that what is the meaning of real numbers. Real numbers are comprised of natural numbers, whole numbers, integers, rational numbers and irrational numbers. And we all know that natural numbers are also known as counting numbers, such as 1, 2, 3, and it goes infinitely. And whole numbers and natural numbers, what is the difference? That too we know. If you add 0 to the natural numbers, it will become whole numbers. So examples of whole numbers are 0, 1, 2, 3, 4, 5, which we studied in class 6. Again, if you look at the natural numbers, negative of natural numbers and 0 together, that forms integers. That's the third category of numbers. And the fourth category is rational numbers. And we all know that rational numbers are numbers which can be expressed in the form of p by q, where p and q are integers and q is not equal to 0. And the decimal representation of rational numbers are either terminating or non-terminating but repeating. And then we studied about irrational numbers. Irrational numbers are numbers which can not be expressed in the form of p by q, and the decimal expansion is neither terminating nor repeating. For example, pi or 2.34, 344, 3444 and so on, which does not have any repeating block at all. So now the natural numbers and whole numbers and integers and rational numbers together makes one part, and irrational numbers makes the other part, and togetherly rational numbers and irrational numbers together make the group of real numbers. So this chapter is mainly dealing with the concept of real numbers and the operations on real numbers. The first point which you have to study from this chapter is Euclid's division lemma. Now, once we say about division lemma, you don't have to worry about the term lemma. Lemma is simply a proven statement which is used for proving the other statements. So lemma is a proven statement used for proving another statement. And there is a closely related term, that is algorithm. And generally we have a confusion between lemma and algorithm. So understand properly, lemma is a proven statement, whereas algorithm is well-defined steps. How do you come to the conclusion or the solution of a question? There are well-defined steps for solving it. That is known as algorithm. So we will discuss about algorithm in detail now in this chapter. So before that, let's go back to Euclid's division lemma. Now, what does it state? According to Euclid's division lemma, given positive integers a and b, there exist unique integers q and r satisfying a is equal to bq plus r, where r is less than b but greater than or equal to 0. It's very simple to understand. When you are given two positive integers a and b, then you are having two sets of unique integers q and r, where r is less than b and greater than or equal to 0. Now, once we say this, it's very easy to prove through the division algorithm. Now, all of you know what is division algorithm. Division algorithm is dividend equal to divisor into quotient plus remainder. Let's just take an example. When you divide 25 by 7, the quotient is 3 and the remainder is 4. Or take another case, 54. When you divide by 11, you will get the quotient 4 and remainder 10. Take one more example. If you divide 84 by 17, you will get quotient 4 for 17, 68, and the remainder is 16. Or take another case, 98. If you divide by 7, you will get 14. 14 sevens are 98 and the remainder is 0. Now all these cases you will find one thing. The remainder is always less than the divisor. Remainder is less than the divisor. 10 is less than 11, 16 is less than 17, and here remainder is 0. So what can we conclude that? The remainder is always less than the divisor or it is equal to 0. So remainder is always less than the divisor but greater than or equal to 0. Now let's see once again this one. Dividend is equal to divisor into quotient plus remainder. That is actually what Euclid's division lemma is all about. Dividend equal to divisor into quotient plus remainder. And the remainder is less than the divisor but greater than or equal to 0. So we can simply say Euclid's division lemma is actually what we know, that is a division algorithm. But only the term division lemma, the term is used like that. So you have to remember, according to Euclid's division lemma, given positive integers a and b, there exists a unique integer. Exists unique integers q and r such that a is equal to bq plus r, where r is less than b but greater than or equal to 0. Now, the other way we can say Euclid division lemma is closely related to division algorithm, or division algorithm follows what Euclid's division lemma states. So using Euclid's division lemma, we solve problems with the help of division algorithm. So let's see how can we do it. Euclid's division algorithm or division lemma is mainly used to find the HCF of numbers, and which you already studied in class 6. Example, let's find the HCF of 56 and 98. And all of you know how to find it, still let me repeat it. 98, when you divide by 56, the quotient is 1 and the remainder is 42. Now what you need to do? Again divide the previous divisor, that is 56, by 42, the remainder of the previous case. Then you will get quotient 1 and the remainder 14. Now what happened? This 14, the remainder will be the divisor next time, and the divisor, the previous case, will become the dividend. So 3 into 14, 42, you got 0. So we have to continue this process till we get the remainder 0. What we do? First you take the larger number, divide it by the smaller number, you get a quotient and the remainder. Then take the divisor of the previous case and divide it by the remainder, whichever you got, and you will get again a new remainder. Check whether it is 0 or not. If it is not 0, again take the previous divisor and divide by the remainder. Then you will continue to get the remainders and check whether you are getting the remainder 0 or not. When you get remainder 0, that particular case, what was the divisor? That divisor will be the HCF. Let us see here. When you divide 98 by 56, quotient is 1 and remainder is 42. Remainder is not 0. We continue. The 56 was the previous case divisor. That 56 is written here and it is divided by the previous case remainder, that is 42. That become the divisor now. 42 into 1 is 42 plus 14, 56. Remainder is not 0. Continue the operation. Now the 42, the previous case divisor, will become the dividend now, and previous case remainder 14 will become the divisor now, and the quotient is 3, and this time we are getting remainder is 0. Since remainder is 0, what was the divisor that time? 14. So 14 is the HCF. So this is the concept. So how can we generalize it? Take the larger number, divide by the smaller number. You will get a remainder, and take the divisor of the first case as the dividend of the second case. Again get the remainder. If it is 0, the divisor is the HCF. If it is not 0, again divide it, taking the previous case divisor as the dividend, and continue the process. So let's take one more example, a larger number. Now here find HCF of 3,556 and 3,224. It's a very larger number, but division is very simple. So what we do? We will divide 3,556 by 3,224. Quotient is 1 and the remainder is 332. Since the remainder is not 0, that will form as the divisor for the second case. And what was the divisor in the first case? That will be the dividend now. Quotient is 9, remainder is 236. Again, remainder is not 0. So that will become new divisor. And what was the previous case? Divisor will become the dividend now. Now 332 divided by 236. That is 1 quotient and remainder is 96. Since remainder is not 0, we have to continue it. Now 96 is the new divisor and 236 is the new dividend. Once you divide it, you get a quotient 2 and the remainder 44. Again 44 is not equal to 0, so that will become the new divisor. And 96, the previous divisor, will become the new dividend. Divide it again, you are getting the remainder 8. Continue the process till you get 0. And when you get the remainder 0, that time the divisor was 4. So 4 is the HCF. And you always have to follow this step. According to Euclid's division lemma, A is equal to BQ plus R. This step you have to write down. Then you show the algorithm in this way. Dividend equal to divisor into quotient plus remainder. And continue till you get the remainder 0. When you get the remainder 0, what is the divisor? That will be the HCF of those two numbers. Now, what will happen when there are more than two numbers? Let us see. How to find HCF of three numbers using Euclid's division lemma. So, this case what we need to do is that take any two numbers. Whichever the two numbers, no matter. Just take any two numbers and find HCF of those two numbers. And with that HCF and the third number, again you find HCF. The final HCF will be the HCF of all the three numbers. Let's take an example. We need to find the HCF of 48, 72 and 240. Let's take the first two numbers. When 72 is divided by 48, the remainder is 1. Quotient is 1 and remainder is 24. So the new divisor will become 24 and the previous divisor is the new dividend. It's 48 divided by 24. 48 divided by 24 is 2, remainder is 0. Since the remainder is 0, the previous case divisor, that is 24, is the HCF of 48 and 72. Now what we need to do? We need to find the HCF of the third number, that is 240, and the previous HCF, that is 24 was the previous HCF and the third number is 240. So you will find the HCF of 24 and 240. Now we know 24 is divisible, is a factor of 240, or 240 divided by 24 is 10 and the remainder is 0. Since remainder is 0, the HCF is the previous divisor, that is 24. So HCF of all the three numbers is 24. It is the highest common factor. Now, what are the other applications of Euclid's division lemma? One is Euclid's division lemma can be used for solving word problems where HCF is involved. And another is to find the properties of integers. Let's take an example. Show that any positive odd integer is of the form 4q plus 1 or 4q plus 3 where q is some integer. Let us see this question. Now in this type of questions you have to be very clever to solve it. You don't take any number as the divisor. Now see, in this case is 4q plus 1 or 4q plus 3. So what you need to do is that you follow Euclid's division lemma and you write down A is equal to BQ plus R is Euclid's division lemma. But since it is 4 here, take divisor as 4. Means B is equal to 4. You take it. And once divisor is 4, remainder will be always less than divisor. So remainder will be either 0, 1, 2, 3. It cannot be equal to 4 because divisor is 4. So remainder will have 4 values, that is 0, 1, 2, 3. So By Euclid division lemma, A is equal to BQ plus R, where we are taking B is equal to 4 because it is here already. So according to the question, you have to take the divisor, and once you know the divisor, you can find the remainder. So let's see how can we solve it. Now A is equal to BQ plus R. Now R can have 4 values. If R is equal to 0, A will become 4Q. If R is equal to 1, A will become 4Q plus 1. If R is equal to 2, A will become 4Q plus 2. And if R is equal to 3, A is equal to 4Q plus 3. So you are getting A can have 4 values. You are getting 4 values for A. Now, but it's given any positive odd integer. So A has to be positive. Now, what is the meaning of odd integer? Not a multiple of 2. So, but you know here you are getting A is equal to 4Q is a multiple of 2. 4Q plus 2, which is equal to 2 into 2Q plus 1 is a multiple of 2. So 4Q and 4Q plus 2 are even numbers because they are divisible by 2. And if these two are even and other two are not divisible by 2, so they are odd. So we can say that 4Q and 4Q plus 2 are even numbers, therefore other two are odd numbers. What are the other two? 4Q plus 1 and 4Q plus 3. So for any positive odd integer, 4Q plus 1 and 4Q plus 3 are odd. So remember, what is most important part is how to find the divisor. If you don't take divisor properly, you will have a problem. Okay, let's take another example now. It's an application based question. You need to understand such types of questions very clearly. A sweet seller has 420 Kaju burfis and 130 Badam burfis. 2 sweets items she has. She wants to stack them in such a way that each stack has the same number and they take up the least area of the tray. What is the number of sweets that can be placed in each stack for this purpose? Now, what is the number of burfis can be placed? Now, when we talk about this, you need to understand the question. 420 and 130. You can place 1 also. 1 Kaju burfi, 1 Badam burfi. Or 2 also. In a stack, 2 Kaju, 2 Badam. Or 3, no, not possible. Now, like that, 5 also you can place it. Now, the thing is that what is the highest number you can place it? You can place 5 stacks also, but here we need to find the highest number, highest common factor among them so that we can keep that many numbers in each stack. So for that, what we need to do is that we need to find HCF. So let's find the HCF. But most important part is understanding the question and say why you need to find HCF. Because you need to find the highest common factor among them, or which is the common factor of 420 and 130, which has got the highest value, so that we can place them in the maximum numbers in each stack so that the area consumed will be less. So understand the question always very clearly. So HCF of 420 finding is very easy, but important part here is to understand the question. And remember, now we know that we are discussing about Euclid's division lemma, so we will find out HCF. Later on, at the end of the chapter or at the end of the year, you will not know which chapter or which question was this one. So it's very important for you to read the question and understanding the meaning of the question. So here, now we understand why HCF is to be calculated. So now HCF of 420 and 130 is to be calculated. Now 420, once you divide by 130, the remainder is 30. So you have to continue again. 30 will be the new divisor. 130, the previous divisor, is the new dividend. You divide 430 by 30, you will get to 120, remainder is 10. Continue it, and when you divide 30 by 10, you are getting the remainder 0. Once the remainder is 0, the divisor is 10 at that time. So 10 is the HCF. So you write down it in the proper format, that is dividend equal to divisor into quotient plus remainder. So you are going to get the HCF of 420 and 130 is 10. It means that in each stack there will be 10 Kaju burfi and 10 badam barfi. That is the highest value which you can use it. So remember all these types of questions. You need to understand very properly how can you do. So there are more application based questions. You have to practice yourself and see whether you are able to understand it or not. In case if you have any doubt, keep asking me. You just write down in a piece of paper, click it and send it to me through WhatsApp. I will explain you and I can give you some audio clips also that if it is required. Okay, let's take another question. Use Euclid's division lemma to show that the square of any positive integer is either of the form 3m or 3m plus 1 for some integers m. Now here again you can see the form 3m or 3m plus 1. So what you need to do, immediately think that let me take b, the divisor is 3, and once divisor is 3, remainder will be less than 3. So it can be 2, 1 or 0. So let's start with, by Euclid's division lemma, we know a is equal to bq plus r. But now let's take b is equal to 3. Then a will become 3q plus r. A is equal to 3q plus r. And when a is equal to 3, b is equal to 3, the remainder is always less than the divisor. So r is equal to 0, 1 or 2. So a is equal to 3q plus 0 first case, second case 3q plus 1 and third case 3q plus 2. It means that when remainder is 0, a will become 3q. When remainder is 1, a is equal to 3q plus 1 and remainder is 2, a is equal to 3q plus 2. What we have done? We have taken the divisor 3. So correspondingly we found the remainders. There are 3 values for remainder. Remember, whatever the value of the b, that much values will be there for remainder. If b is equal to 3, there will be 3 values for remainder. Remember that. Now, when a is equal to 3q, that is when the remainder is 0, a is equal to 3q, we need to square it because question is show that the square of any positive integer. So a is equal to 3q, then square it, that is a square is equal to 3q whole square. That is 3 square is 9 and q square, that is 9q square. A square is equal to 9q square, which can be written as 3 into 3q square because we want to get it in the form of 3m. So it is 3 into 3q square, that is 3 into m, where m is equal to 3q square. So the first part, when remainder is 0, we can find that the square of the integer is of the form 3m. Now let's go to the second part, that is when the remainder is 1, a is equal to 3q plus 1. If you square it, a square is equal to 3q plus 1 whole square. We know that this is of the form a plus b whole square, which is a square plus 2ab plus b square. That is 3q whole square is 9q square. 2ab, 2 into 3q into 1, that is 6q plus 1. That is 9q square plus 6q plus 1. Now, this we have to make in the form of either 3m or 3m plus 1. What can we see here? In the first two terms, 3 is common. So let's take 3 outside. So 3 into 3q square, 9q square. 3 into 2q, 6q. So 3 into 3q square plus 2q plus 1. Which means 3m plus 1. Where m in this case is 3q square plus 2q. So m is equal to 3q. It doesn't mean that this m and this m are same. Only this is a form. It can be expressed in the form of 3m plus 1. Because these two can never be equal because the remainder is different. So what we have done, we have squared that. Then we have made it in the form 3m plus 1. Now let's go to the third case. When r is equal to 2, a is equal to 3q plus 2. Then a square is 3q plus 2 whole square. Which is 9q square plus 12q plus 4. That's equal to 9q square plus 12q plus 3 plus 1. Now, why have we written like this? Now, see here, a square, that is 3q whole square, that is 9q square. 2ab, 2 into 3q into 2, 2 into 3, 6 into 2, 12q, plus b square, 4. But this will not form in the form what we need, 3m or 3m plus 1. Now, if you take 3 common, the first two, if you take 3 common, that will become 3m plus 4. But we need 3m plus 1. But we know 4 is equal to 3 plus 1. So what we do, we split 4 as 3 plus 1. So you can see the first 3 terms will have 3 common. So we take 3 outside and then outside it will become 3 plus 1. That is 3 into 3q square plus 4q plus 1. And plus 1 outside it. That is 3 into 3q square plus 4q plus 1 plus 1. That is 3m plus 1, where m is equal to 3q square plus 4q plus 1. So square of any positive integer is either of the form 3m or 3m plus 1 for some integers. So you keep practicing of these types of questions, and if you have any doubt, you just ask me. Whichever questions you have doubt, I will explain it to you. So thank you very much. We will meet again.